right, so today we're going to be talking about similarity in volume and surface area. We actually did similarity in areas last unit. Remember when I made that chart with y'all? Some of y'all were like, I don't know what's going on in here. Hopefully this will solidify that. So in your notes, page 62, did y'all title this? Okay, so the first thing I want to rehash is that chart we did. Let me make sure it's focused. All right, look, I got my nails redone, even though I don't like them, but I got them redone. Okay. Remember we did, I know, it's okay. Scale factor, we did 1D and 2D. Do y'all remember that? Yeah. A little bit? Okay, now we're going to add a 3D column. Okay, so remember, scale factor is just your scale factor. How do we find scale factor? Back, new over old, or we did second over first. So for this example, I'm just going to do B over A for my new over old. Are y'all okay with that? You're writing this down. Okay? 1D. What was 1D? What did I say that represents? Do y'all remember? Perimeter or a side. And what does this give me? It's going to be the exact same. B over A. So whatever your scale factor is, if you're trying to find the effects on the perimeter, it's going to be the same as the scale factor. What does 2D represent? Area. And what do we have to do? Square it. So it was going to be B squared over A squared. What do you think 3D represents? Cubed volume, and we're going to cube it. Sorry, I'm writing sideways. It feels a little weird. So what if I say the scale factor is 4 over 3? What is going to be my ratio of my perimeters? 4 over 3. It's going to be the same. What about the ratio of areas? 16 over 9. And the ratio of volumes?
64 over 27.
Bam. And that's all we're doing today. Kind of.
That's it?
Kind of. No. No. So, here is example number 1. I would like you to write in your notebook, please. I'm gonna talk all about that. Write this down and then I'm gonna go over it with you. Okay. It says find the similarity ratio of 2 cubes with volumes of 729 cubic centimeters and 1,331 cubic centimeters. So when you see that word ratio, that tells you you need to do your chart. Are you okay with me doing the scale factor / 1D in the same column because they're going to be the same every time? Okay. So then I'm going to do 2D and 3D. What do I know? I know volumes, so what column is this going to be in?
3D.
Which one goes where?
13, 31 goes on top.
It's second over first. Now, you can never go from 3D, in between 3D and 2D. Everything has to stem from this first column. So I'm going to put an X here just to remind us that we can't go back and forth between these. From 3D, where do I go? How do I go? What do I do to get that? Cube root it. Not square it, but cube root. So I'm going to go to math, go down to 4. Please use alpha y equals. It gives you fraction and it makes it way prettier than you just dividing. So alpha y equals enter, and I got 1331 over 729. So what is my scale factor? 11/9. So that is my answer. That's my scale factor, my similarity ratio. Okay? Any questions? Can I change it? Example 2. A marble paperweight shaped like a pyramid weighs 0.15 pounds. How much does a similarly shaped marble paperweight weigh if each dimension is 3 times larger? So you can do example 2. You don't have to write all of this down, but maybe write down what I'm going to write down. What do I know? So what's 3 times for me? That's my scale factor. 3/1, 3, same thing. That's fine. What do I want to know? If it's weighing, what dimension, what is that? That's 3D, that's my volume. So what am I going to do from here to here? Cube it. When I cube it, what am I going to get? 27. Okay, so now that I know that my ratio of volumes is 27, that's my answer? No, what's my question here? I want to know what the weight of the new paperweight's going to be. So what am I going to have to do?
Multiply the pound, the weight.
I know my old one was 0.15, and I need to multiply it by that. So what's my new paperweight going to be? .05. So my new paperweight is 4.05 pounds. So remember, in this chart is always ratios. It's not going to be your actual weights or anything like that. If I asked you how much larger it was, the volumes were, then you would say 27 times larger. But if I'm asking you for the actual amount, then you have to multiply it. Okay? This next one you don't need to write down, but I just want you to look up. If you want to write down, you can though. Okay? Okay. 2 similar prisms have sides in a ratio 4:7. What would be the ratio of their surface areas? What would be the ratio of their volumes? So, what do I know? What's my scale factor? Why is it 7/4? Perfect. So that's going to be 2D and 3D. So what is going to be my scale factor of their surface areas? 49/16. Be careful. Make sure you don't tell me 14/8. We're not doubling it. We're squaring it. What about for 3D? For volumes? What's 7 cubed? You'll catch on to that one real quick. What's 4 cubed? 64. So what is my ratio of their surface areas? Ooh, surface areas? What is my ratio? What is my ratio of their volumes?
64 to 33.
That's going to be, okay. We good? Okay. Next one is very similar to this. A rectangular prism has dimensions of 1/4/9. Find its volume. So if I'm 1/4/9, how do I find the volume? I could use area of the base times height, but that's essentially length times width times height. So what's my volume here? Inches cubed. Okay. If each dimension is multiplied by a scale factor of 5, then what will happen to my volume? Well, what do I know? What's my scale factor? Is 5. What am I messing with? 2D or 3D? I'm messing with volume, so what am I going to do from here to here? So what's 5 cubed? That's my answer, 125? So what will happen to the volume? It'll be 125 times bigger. No, it'll be 125 times bigger. So what will be my new volume?
125 times.
will be 36 times 125 inches cubed. Does that make sense?
No.
What part does not make sense? So do you get how I got 125?
Yeah.
Okay, that is my scale factor of my volumes, my ratio of my volumes. So to figure out what my new volume is, I have to multiply that by my original volume. So that's how I got the 4,500. Does that make more sense?
Yeah.
Okay. All right, next one. A cone has a radius of 6 feet and a height of 18 feet. If each dimension is multiplied by a scale factor of 1/3, how will this affect the volume? How will it affect the surface area? What do I know? My scale factor is 1/3. So how is this going to affect my volume? So the 1D perimeters will stay the same. What will happen to my volume though? That's my 3D. What will it multiply by? Which is what? 127. And what about my surface area? What will happen to my surface area? 1/9. Does that make sense? We good? All right. How many of the smaller cubes will fit inside the larger cubes? Pause. Don't answer. Think about it. So many of you are so quick to answer it, you get it wrong. Okay, now answer. Now y'all don't want to answer. What were y'all going to say right away? Y'all were all going to say 5. Why? Okay. What is my volume of my small cube? No, how do you find it? I mean, yes, you're right, but how do you find it? 5 times 5 times 5, which gives me 125. What is the volume of my large? What's 25 times 25 times 25? Thank you. And what do I need to do to these two? And when I divide them, what do I get? So 125 small cubes fit in the big cube. Do you see, hold on real quick, do you see how we could get this wrong because we just look at them divide and we're like, oh, 5. Oh, but so many of you, because guess what? I'm going to put 5 as an answer choice.
Now I know.
Please work it out. What's your question, Hassan? Oh, okay. I thought your question. Okay. Now, for these next problems, I'm going to do one. I know there's 6. I'm not doing the last one. I'm going to do one, and you're going to do one, and then I'm going to do one, and you're going to do one. You can choose to write down all 4 because maybe you're like, oh, I need to really write this down. Or you can just write the one down that you're going to do, and you can watch the first one. It's up to you, but either way, you need to have 2 written down. Are we good? Okay, so the first one I'm going to do for you. And actually, let me see if I can zoom in so I can. Okay. And I don't want you to look at this yet. So, it says the surface area of 2 similar figures are given. The volume of the larger figure is given as well. Find the volume of the smaller figure. So, what do I know? Surface area. So what do I do with those? I need to make my chart. So I'm going to have scale factor / 1D, 2D, and 3D. Well, oh, sorry, thanks. How am I going to write it in 2D? So usually the second one is the new and the first one is the old. I'm going to tell you in a second how it doesn't matter for this case. What do I do now? I need to find volume. So can I go straight over to 3D? Remember, there's an x here. You can't go from 2D to 3D. So what do I have to do? Square root it. I got to go back. So, again, please use alpha y equals because it's just going to save you time. What did I have? 558 over what? 248. So square root, what is my scale factor? 3 over 2. Now that I know my scale factor is 3 over 2, what do I do? Cube it. Correct. What is 3 cubed? What is 2 cubed? 8. Alright, so now, my answer's done? No. I need everybody to look up, please. If you're writing, I just need you to pause. Everybody look up. Which volume am I given? The large volume. So this is the large volume. If this is my scale factor for my volumes, so I'm going to have to multiply this by this, right? But if I do that, 27 over 8 is larger than 1. Do you agree? If I multiply that by that, aren't I going to get a larger number? So what can I do? I can either do one of two things. Technically, I could divide 810 divided by that. That's kind of ugly. I think David was the one that said, I can do the reciprocal. So, I'm going to multiply my large volume of 810 by 8 over 27, because that'll give me the smaller answer. So when I do that, I get 240, which is my smaller volume. Inches cubed. So, if, let's say the directions were changed, and I told you this is the small volume, find the large volume, what would you do? Multiply it by 27 over 8. So back to what Hassan was saying, how do you know which one's second and which one's first? Really, when you're doing the chart, it doesn't matter. You just need to pay attention to, if I'm looking for the larger number needs to be on top. If I'm looking for the smaller number needs to be on top.
Like, we'll do that every time because that's the smaller.
Correct. Correct. Does that make sense? Okay. Now, your job is to do number 12 in your notes. Go. Here. Miss Dang's class, you should be working on this one. Go. Oh, yes. Or you can divide. Yeah. Yeah, you can just divide. Did we get that? It's okay. I'm not.
Oh, that, yeah.
Okay. What did we get as our scale factor?
3.
What did we get as our scale factor?
Oh, yeah.
Okay, because we had to square root it, we got 3. You can leave it a whole number. You don't have to make it a fraction. Okay, I'm going to give you one more time. What is my volume ratio or volume scale factor? 27. So the 27 is my answer?
Oh, I was.
No. Now, I don't have a fraction, so I don't have a smaller number, a bigger number. If I have the bigger, what can I do? No, I have the bigger. This is the larger. Oh, you can multiply by the reciprocal, or you can just do what? Divide. So for my smaller, 4860 divided by 27 gives me 180 meters cubed. Okay. Now I'm going to kind of, can I change it? Okay, I'm going to flip the script on you a little bit. You ready? This time, what am I giving you? Volumes. And what are you going to need to do? Find the larger surface area. So the smaller surface area is given. So, again, you don't have to write this one down, but you can. If I have scale factor and 1D, 2D, and 3D, what column do these go in? Why 3D? Because it's volume. Okay. What do I do from here? Okay, can I go straight to 2D? No, I have to cube root it. What's the cube root of 125? And the cube root of 27? You're going to learn those numbers real quick, just because we'll be doing them so much. Sam, you with me? Okay, now what do I have to do? Square them, and so I get 25 over 9. What do I do with this? Is this my larger or my smaller surface area? Smaller. So to find the larger, I have 63. I'm going to multiply by, the bigger number needs to be on top, because I want the bigger surface area. So what's that give me? No, it shouldn't. Ah. Okay. Is that right? So I get 175 inches what? Because I'm doing surface area, it's squared. All right. Correct. This time, find the larger. You do number 15. Go. What is the cube root of 64 over 27? So to find the surface area, what's my ratio? So I have 63. I'm looking for the larger, so I'm going to keep the number on top. And what do I get?
112 meters.
Does that make sense?
Yeah.
Okay. Can I change this?
Yeah.
Are we okay? Okay, I'm going to blow your minds a little bit. Are you ready? Okay, put your pens down. And then I'm going to talk for hopefully only 2 more minutes, and then we're done. Normally I label these perimeter, area, and volume. The reason I do not is because of this next question. A gift box has dimensions 6 by 8 by 12. If we triple the height only, how will the volume be affected? Normally, what have we been doing? Normally, what have I been doing? I've been tripling what? Everything. Now, I'm tripling the height only. What's that going to do to my volume? Well, remember how I call it scale factor 1D, 2D, and 3D? What's my scale factor here? What's my scale factor? Tripling is 3. How many dimensions am I tripling?
1.
So what's going to happen to my volume? It's going to be 3 times as big as my original volume. So if you're only tripling 1 dimension, then your volume's going to triple. What if I said I'm going to triple my height and my length? That's 2 dimensions I'm tripling. So what will the ratios of their volumes be? No. What do we do from here? Times 9. Because I'm changing 2 dimensions. And then what if I say I triple all of them? It would be 27 times. Do you see how that's going to happen? Will that be every time? No, not at all. But it will happen sometimes. So now you're ready for the mind-blowing part.
Is this going to be on your test?
No, this part will not be on your TEKS test. What if I double the radius?
That's just the diameter. Right?
How many dimensions is a radius?
I don't know.
Think of the area of a square. What's your formula for area of a square? Pi r. How many dimensions is a radius? I'm not saying a radius is a base and a height. But isn't a radius like a base and a height? Your radius is 2 dimensions. That's why we square it. So if I double the radius, what's my scale factor? What's my scale factor? It's doubling, so it's 2. And I'm doubling the radius. How many dimensions is a radius? A radius is 2 dimensions. So what will I be doing to my volume? So what's 2 squared? So my volume will be 4 times as big. But what if I only double the height? How many dimensions is a height? 1 dimension. So if I double the height, what's my scale factor? 2. How will my volume be affected? Multiply by 2, because it's not 2 dimensions, it's not 3 dimensions. The height is only 1 dimension. Does that make sense? What if I double both my radius and my height? What's my scale factor? It would be 3D, because radius is how many? Height is how many? So total that would be 3D, which would be doing what? Times 8. Does that make sense? Okay, so my point is, what if I double both the radius and the height? How many dimensions is that? That's all 3 of them. So then I have to go to my 3D, which when you go to your 3D column, what do? Cube it. And so what's 2 cubed? 8. Okay. All right. That's all for today. Thank you very much, guys. Sorry it took so long. Thanks. Bye.